In this part of lecture, we will be considering image processing operations which are enlisted here in this third bullet, what you can see there. Basically, these are the components which are present in our this module, where we will be talking about digital image processing operations. Means operations of what kind? It is arithmetic kind of, like simple addition, multiplication, division, this. Then we will do some operation which are basically logical operations. Directly by using your logical gates, how we do operation in image processing, that will be taken in that. Another thing is that geometrical operations, just like if you want to rotate an image or make it of another shape, those kind of geometrical changes of the image, if you want to make those, how it is done through some operation, that will be discussed in the other one. And then also another application is that if you want to interpolate the image, if it is there existing in some shape, you want to interpolate from the existing values of the image intensities, that is also possible there by some operations which will be discussed there. Another point is the set operation, where image will be represented in terms of set, and set theoretic approaches, means mathematical set theoretic approaches will be taken there to operate the image or to do operation on the image. Later we will go for statistical operations also, where if the noise image is noise corrupted, so in that case the statistical approaches are used for enhancing the image or restoring the image or manipulating the image in desired form. And later finally again another we will go for convolution or correlation operation on the image, what we have discussed little, which is basically if one image is transferred from one place to another place, through that channel when it passes, that may got deformed. For restoring the image or doing some desired manipulation on the image, that can be also done by some operations which we will be covering here. But before going to those discussions on image operations, the related terms or metrics which are very much relevant and which will be coming frequently while discussing these topics there, those will be discussed at the beginning today in this lecture, where basic relationships and distance matrices will be discussed in this part of lecture. So let's proceed for the first 2 points. Here, let us start from very beginning, where we did image acquisition by sensors, and we imaged that in an internal image plane, which is given in the figure A and mentioned as analog intensity, which we have acquired through the sensors, and in terms of voltage, which you have represented some analog signals there. Now you have discretized them depending on the ability of yours to define the smallest area of the total area, so that by which you can define the full area that is given there, and individual area has the same intensity, and that can vary only if you go for the next square unit there which is given. So that is called discrete intensity values which are represented in it. Now I will ask you to notice into each and every squares there which are our interest, where the center of it is considered pixel of the image. So number of pixels used for representing this image is equal to the number of square units which are given there. So now onwards, what I will speak about, those are small points where it is shown here, these are actually the center of individual squares. Now if the centers of individual squares are representing some intensity values, that may be in terms of voltage or current we represent, but those are intensity values represented for individual spatial locations which are the centers of individual squares there, they will have some intensity value. Those are represented as fxy, where xy are the coordinates, which we consider here as a discrete coordinate from 0 to m-1 and 0 to n-1 respectively for x and y coordinate. So those are represented in matrix form here, where all the pixel values corresponding to individual squares there are considered and are available in fxy depending on different x and y values. Now those individual f and xy, if I am going to analyze this fxy values of this arrangement, then I can say these are the individual pixels in which I would like to know whether this pixel and this pixel has the same value or not, or if they have the different value, how much different it is, or if this pixel has some value and this pixel has some value, are they same or they different? Those are the pixels or the intensity values corresponding to a single image, which is represented here. So I am talking about the pixels which are nearby that particular pixel with which for which I want some information. Like say I am considering a particular pixel, this one means pixel value fxy, which will be corresponding one pixel there, and for that I want to know what are its neighbors, means around it what are the intensity values with which I may like to compare the intensity value of that particular chosen pixel. This is the idea behind. So I will be picking up any xy coordinate, for that the pixel value I will be considering, and then I will try to see other pixels which are nearby, or maybe it is far, does not matter, but in that image itself if they are there, they maybe their nearer neighbors or further neighbor, that hardly matters, but with respect to this, these all are the neighbors. Maybe they are located at various places, some are closer, some are farther, that does not matter, but we are talking about the neighbors of a pixel. Okay? So these are the neighbors. Now if I want to find their relationship, some criteria should be there with respect to which I will be finding the relationship. So those relationship can be of anything, like their location with respect to it, distance should not be of a particular unit, or intensity should not vary beyond this particular limit. This way many criteria can be fixed there for defining the characteristics of the pixel with respect to its neighbor. So that way one term is this adjacency, which we will be defining after this, how the adjacency is found there. Next we will go for, if these pixels are found there, they have the intensity values, then I have found some relationship between them, how they are related. Just like for example, if I identify them with the intensity values, now I can ask that my computer that please find those pixels who are having same intensity values. I can ask, in that case my computer will locate the, or it will give a locus through which these points are moving there, or it will try to travel a path. So that way this path term will come into picture. We will see that also immediately after this. Then few important terminologies which will automatically come there after this, we will see there, just like boundary, region, edge, this kind of things which are very popular in image processing, those also will be defined with respect to this fxy values, means absolute value of fxy I am talking about, or who are the representative of intensity values. So please don't deviate from that point. If I am talking about some numerical value, that is actually value of fxy. How does it different from our 10 or 001, 110 or digital numbers? It is actually different. This fxy is a discrete value of that amplitude, not its digital value. Discrete value means you have made the total range of variation in some number of levels. They have individual leveling of those particular levels there. Now if you have labeled them, different levels are labeled with some value. So one is 0 volt, one is 1 volt, one is 2 volt, one is 3 volt, like that. Those 1, 2, 3 volt, those I am talking about, those are fxy. Unless and until I make analog to digital conversion, that doesn't give the digital value. So please don't confuse with that. We are talking about fxy means we are considering the absolute discrete value. I cannot say analog value. It is a discrete value because analog is discretized, so it is deformed from the analogy to the physical happening. Some deformation is there. Only thing is that it is not made analog to digital conversion. Fine. So if the values I am talking about of fxy or some pixel value, that you should consider those intensity values. Now, before I give you the actual intensity values or take the example with the actual intensity values, let me define few terms which are named as their neighbor of a particular pixel, which is mentioned here P. Say, out of that total matrix or total image, you have identified a particular pixel P there. This is a sub image of the total image. It has its neighbor around it. Now, let us name them. Let us name them those pixels which are around this P. Let us say, first I am saying, I will find the neighbors which are either in vertical direction or in horizontal direction. That means, if the pixels are in vertical direction or in horizontal direction, I will identify them, I will name them as N4, which are named there. Those will be called 4 neighbors of P pixel. P is the pixel location with respect to which they are the 4 neighbors of P, and they will be kept in a set, or they will be made a group. That group will be named as N4P. Okay? Next, people may ask that, why should I go only for vertical and horizontal? I am seeing some neighbors are there who are diagonal also. Let us take those now. Those who are diagonal to this, let them named as ND. Them means those locations I am naming. The coordinate of them I am naming actually. Okay. Now, those will be called diagonal neighbors of P. Who has a coordinate, say xy, one arbitrary coordinate xy I have considered where the P is pointed. Those will be named NDP. That means I have made a group where those locations will be kept in my memory, that these are the diagonal or NDP of that P pixel, which is a location x comma y. But actually speaking, if you see, the neighbors are here are union of those N4 and ND. Nearest neighbors I am talking about basically. The immediate neighbors are found as N4 union ND, means all together. So, let us take union operation of N4P and NDP, so that I get a set which will be containing the locations of all the neighbors around the particular pixel P, and let us name them as N8, because 8 are the only possibility around it. So, those neighbors are named as 8 neighbors of P located at x comma y. Okay? So, whenever I take these terms now onwards, you should quickly think about those locations. Now, the time has come where we can define adjacencies, where those ideas what we have taken just now, 4, 8 and another term M is there, which I will be discussing after this, 4 and 8, which have come automatically there, because these are the neighbors I am talking about, for which I will like to find some relationship of my pixel P, which is located at x comma y. So, while searching or while going for that operation, I can go in a vertical or an horizontal path. If I go that way, I will face the N4 elements or the set where N4 components are present, or I can go for all which are union of ND and N4, or I will call N8. So, if I go through N4 approach, those adjacencies, the relationship what I will get, those will be named as 4 adjacency, and for 8 it will be 8 adjacency. Fine. Now, in this, most important part of this slide is this one, because I am talking about adjacency where I need to get a relationship between the pixels. Say I have a pixel at the center here with respect to which I will be finding the adjacencies, that may be 4 or maybe 8. But with respect to what? With respect to a particular intensity value. Say like I have intensity value 1 here, 0, 0, 0, 0 here, and for this these are 1. These are not digital bits, these are absolute intensity values. Now, since I am saying there my desired pixel Pxy is with intensity value 1, let me find the others, means 4 neighbors who are with the same intensity value 1. This is the idea behind. If it is so, let me name that condition V, where the intensity value will be 1. So, this is always background in the background. It is considered here that pixel value, those who are having 1 and they are neighbors to the desired pixel P, which is located at the center, I would like to identify them. So, in that case, I am considering this particular pixel and I am searching for the 4 neighbors who are either this and this. These are the 4 points who are the 4 neighbors. Out of them, I have found only this one who is having the intensity value 1, others are not. So, one red line is put there. That means they have some adjacency, means these two are related. Now, similarly, you can take another pixel value here, just xy coordinate you have changed it, where you have decreased x value by 1 and y you have kept fixed, so that pxy has got changed and you have considered this pixel value. Now, with respect to that also, I may find an adjacency conditioned on this V, where V is a set which contains the condition actually. So, there if I find those 2 red marks which are put there, they are the 4 neighbors of that pixel, not the left one. Diagonal zeros are not allowed to consider for checking also. Why? Because I am talking about 4 path or N4, where only horizontal and vertical movement is allowed. That's what it is a N4 neighbor what we are talking about. But scenario could be different if I would consider 8 neighbors. In that case, all I will consider who are there. Take this example here. No, sorry, here. This is the center path, say, with respect to which you want to find who are 1 in N8, where these are all N8. I found this and also this because it is in diagonal, but they are not because they are of other intensity. What is that? ND, because these are the ND, because in N8 he is asking where is ND. Actually, ND is within N8 itself. Why not only that? I can consider that also. He is interested about only ND, just like for N4 we went, for ND also I can go. Depending on my application, I can ask my computer to search that. It's not a problem, it is allowed. Okay. So, we found the N adjacencies, means these pixels are adjacent to one another now. Those who are connected by this red line, they are adjacent to one another. Which way? Through 8 adjacency. Fine. In this, as I said you, sometimes people may like to travel the path. Which way they are adjacent, who are the adjacent pixels, or I will like an unique path to move from one place to another place. Say, I want to move from here to here. If I go from here to here, then this, my path, my red lines are available. Similarly, I can go this way and this way also. This is also available. But here, since 2 ways are there for my travel, I may get confused sometime that which way to go, or I have to take another degree of freedom there to represent that one. So, to avoid that, one mixed kind of adjacency is defined there, which is called the third one, M adjacency, where they will not like to take this other path, where only one way traveling arrangement will be made there, or the red line, those will be kept there, that will be following an unique one. In that case, I may have to travel sometime larger distances, that does not matter. So, for that, if I want to define that, please carefully look into this condition. The way you define the 4 adjacency and 8 adjacency, now we are going to define M adjacency with the condition like this. Like for 4 adjacency, that neighboring Q with respect to P, means whom I am checking, that is Q. is that belonging to the N4 or not? That we went for checking in the 4 neighbors. That condition is there. If you find any N4 is present there in Q, immediately you put the red line. No condition on that. If it is in N4, put the line, no problem. But if you are going for diagonals, then the things come. If that Q is not ND, in that case, that is not only the sufficient condition for which you can put a red line there. You have to satisfy this condition also. This AND is important, because it has to be in diagonal, and then the intersection of N4P and in N4Q, N4P and N4Q, intersection of those two, which will be another set, there will have some intensity values either 0 or 1, the example what we have taken there, they should not be within this. If it is in diagonal, then also red line can be given there, but it has to satisfy that N4P and N4Q, intersection of that should not contain this particular intensity value for which we are finding the adjacency. Because whenever you talk about the adjacency, this comes first. In that case, if you go for this thing, check here for this. Who are the N4? N4, nobody is there, done. Who is the ND? You have gone here, this is the ND. Now check there. If this and this has the N4s, like this and this, they are the common N4 for both P and Q. This is the Q, this is P. Now for this P, N4 are this, and for Q, N4 are this. Nothing is here. So these two are found common to both. If they are with that one, in that you cannot put the line. If they would be one here, you could not put the line here. It is not allowed. Since nobody is at one value, this one value, so you could put this line comfortably. But if you go for this, in this, you are going for checking this and this, which is in the diagonal. For N4, no problem at all. But for this diagonal line is the question. If you want to put this diagonal line, in that case, you have to satisfy this condition also. Now I am seeing there, this is the common and this is also a common element. Now here I am seeing it is 0, but here it is 1. So this condition is not satisfied in this case. While this is P, this is Q. So since this condition is not satisfied, I cannot put this line there. This or this M adjacency speak about. That's why you are seeing the line this way, not the diagonal one, which could be put in the 8 adjacency. This is the difference. That's why I said importance is there a lot to make it different from 8 adjacency. Well, let's take an example here where we will talk about path also. Now these red lines have taken their shape of arrow. Say like we want to analyze this image where the intensity values are given 0, 1, 2, 3, what I said. It can take 0, 1, 2, 3, any value there. Now, in this, two locations are identified, P and Q. I need to find their adjacency with a condition V equals to not only 1, 0, 1. I could put 0, 1, 2. I could put 0, 1, 2, 3 also. That is up to me. Is for which I am asking to find the adjacency. Okay. Now, if I am talking about adjacency, you will ask me that which way I like to find the adjacency, 4, 8 or M. This is the question. At the very beginning, it was with respect to what I have to find, that is V, that is there. But now 4, 8 or M, which way I will find? That is another question. Okay, we will take example for both actually. Let's see, this is the two P and Q points for which we want to find the adjacency, and for which we will be checking there whether the N4 and NDs are there with intensity values either 0 or 1, because both are in V now. If it would be only 1 like earlier, then I would go for only 1, not 0, or it would be only 0, then I would go for only 0, but 2 elements or more than that also it is allowed there. So, if 0 or 1 anything is there, I can move. Okay. So, let us find, say for this element I need to find the adjacency, which is say M adjacency I will be finding. Let me follow that route. First I will be finding N force who are there with values 0 or 1. I could find this is 1 and this is one option, not this, which is diagonal. Even another thing is that this is 2, so it is not coming into V there, so no need to check that, but it could be put this way also. Okay. I have kept it here, then I am going for this one. In that, where are the adjacencies? If you go this way, nothing is there, but here it is existing, so another line. Now, here you have found another path, then here you have found another path, this 0 is there. Now, here it is not there, but in the diagonal it is there. But if the diagonal is there, you have to go for the check. We are talking about M adjacency. Now, you have to consider these 2 pixels there and find their N force who are common to both, means intersection of them. Are they in 0 and 1? I am saying only 2 are intersections, but they have the values 2. So, I will not have any restriction to put the line here. So, line is kept there. Fine. You could move in this way also, but see here in that after this nobody is there to support you in 0 and 1. So, your path is blocked. Okay. So, that is why we took this one. Again you could go this way also. You could move here because it is in N4 1, then you would be finding this adjacency for the diagonal. Is it allowed? Is it allowed? Because I am saying intersection is there which has the intensity value from that V 0, 1, because I am saying 1 is there between these 2 I am talking about. If I would come this way, so this would be the intersection point who is in V there, so that is not allowed. So, this is the unique one through which if you want to travel from P to Q, this is the path through which you should move. That is why it is called path. At the top the title is given path. This way the path is defined in terms of what? Obviously adjacency. Obviously, if you are talking about adjacency, what kind of adjacency? That is defined here as M adjacency. Let us take the example for 8 adjacency. If the path is given for 8 adjacency, obviously the path name will be 8 path. Okay. So, in that if you find the path from here to here, in this you do not have any restriction of those intersections to check. Simply you will be finding either N4 or ND and you will be putting the paths there. So, in that way if you move, you will be moving in this fashion. So, this is the path in 8 adjacency. So, it is 8 path. Now, please find what is the length for these 2. How many unit lengths you have traveled there? Here it is 4, but there it is 5. That may be for M adjacency, but for this 8 adjacency you would have another path also there, that is avoided. Okay. This way the M adjacency has some meaning there. If I ask you, is there any 4 path exist for this example with this V? You check it, you will find no 4 path is available there. Means only 4 path you have to take, no diagonal movement. You will see there no 4 path is existing there. This way they are significant in various applications of your desire. Okay. This way we could find some relationship between the pixels in an image in terms of their intensity values, and then by defining a set V where the intensity values will be defined there, and by considering 4 or M or 8 adjacency. Using those ideas, we will like to know few terminologies there which are relevant to our image processing. First is connected components. Second one is connected set. Third is region. Another one is edge, and then boundary. Let us see which way they are defined with our the ideas what we have acquired just now. I need some adjacency to find in an image. For what purpose? To get some relationship or to get some idea if some connectivity is there between them in some term, like in terms of intensity values. Is there any relationship between them or some connectivity is there between them? Let us find that. To do that, you need that adjacency idea first. So, we have considered one adjacency here. Say, for simplicity, we have considered only 4 adjacency here. If I talk about adjacency, you will immediately ask what is the V value you will take or what is the V set you will take there. Say, I have considered only 1 there. Again, in this example of this image what I have considered, this is a sub image of a bigger image where the intensity values got only 0 and 1 values. It could be 2, 3, 4 also. Okay? Now, in that I would like to know who are the connected components or who are the connected pixels in this image. Let me try to find them. Those who are somehow maybe they are related, or I may need to use them somewhere in my other application. Now, if you identify them, see there few ones are here and few ones are here, remaining are 0. So, small idea can go there immediately that maybe this is one part and this is another part where these two are different from the remaining background. Initial guess I am saying. So, my computer should like to identify them individually if they are there. Let us find them. To take them out or to get the sense from that image which is given to us, let us first define a level matrix of this kind which has a dimension like the subset of image which is considered there with the intensity values 0 for all, but dimension is same. Now, look at one intensity value 1 because V is defined as 1 there. So, find any one from here and identify that location here, just like here. So, which one I have taken? I have taken this one which is red mark there. For that red mark in the level matrix I have put 1 there. It is because I have located that xy coordinate for that location. Now, I would like to find neighbor of it. If I want to find neighbor of it, I can go for 4, 8 or M. So, I am considering 4 at the beginning I have said there, or 4 adjacency is said there with V equals to 1. So, I will be traveling the path in horizontal or vertical direction who has the intensity value V1. Okay? So, you go to this image, find this location and find its neighbors. Who are they? This and this. 4 neighbors. Identify them. These are 2 identified. Okay? But our location was here, which we have already addressed. We wanted to know the neighbor of that location. After I find the neighbor of that, I will like to hide it. Say I have put 1 0 for that, for my understanding or my computer's understanding that it is visited already. Okay. So, for that the neighbors what I found there, those will be written down here along with the earlier one, because here nothing is to change there, because it is the final one which will be coming from the actual image. This is my image, level image, which is kept separately for my analysis. Okay. Now, this is visited. Now these have come to picture. Let us find their neighbors. In terms of what? 4 neighbors. So let us find their neighbors from that actual one. I think you will get another one which was here, but you have already found the neighbors for these two, so you have made them hide 0. Okay? Now that neighbor has come here now, but still that one is red marked in that place. So you have to visit him also, and you have to check its neighbor again. Okay? So in the next step, we are going for checking its 4 neighbor. I have found nothing. So my search is complete there. That in that no neighbor is there of those particular pixels where I have visited. I know them where I have visited, so let them present now in this fashion. So this is all who are visited there. For them, one portion has come out from this image in this form, where this label image, which was at the beginning all 0, but here it is 1 1 1 is found there. So it is a portion where the pixels are adjacent to one another, or they are connected in some manner. So they will be called the connected components. These are connected components. Means this total thing, this portion is a connected portion of this image. What is the image? Image was earlier what we took with ones here. I will come to that at the end. My job is not over actually, because I am saying still in that image few ones are still remaining. Only thing, I stopped my search immediately in between because I didn't get any N4 path. Let me identify another location out of this, any one of it. Let's move for that. In the same manner, I will be putting this one identified by me, and I had visited that one, so I have marked it as 2. This is not the intensity value, it is my labeling actually to it. In the label matrix, I am labeling it. This is the first one, and now this is the second one. With the same idea, I am visiting there and I am seeing 2, then I am moving to another 2, I am hiding the previous one, then I am moving to another one. Finally, I could get all ones are visited in blue color, and those in the label is marked as blue color 2. Okay? So this way, after this, if again I ask for my computer to search if any one is there, it will find nothing. So no search is required there, things are over. So finally, it is presenting the image in this form, where your image was here, which was under process, and that process has given an outcome in this block, which is a label matrix. In that I am finding one group, one set is here and another set is here as 1 and 2 there. Those two are different. So in this 2, in this image, I can say there are 2 connected components. One is this one, another is this one, which is found from this label matrix. Okay? Individually they are connected components, and since 2 are there in that image, I am saying the image contains 2 connected components there. Let's take a single one from here. One part of it. I can take sub-image of sub-image. Say I have taken that one. That part I have taken out here. What is about it? Now, say the locations of those are put to a set, which is actually a subset of the bigger set, if the bigger set is the actual image, or the previous image if you said bigger actual set, and of that one subset S is taken there in this fashion. If you go for searching here, how many connected components you will find? Only one. This way, if you get a single connected component in a subset which is named as S, that will be called connected component or connected set. If only one connected component is there in that region of your interest, you will say that as connected set. Who? That S, whom you have named. This is very important because you will be calling him in some other place. Okay. So, this is that connected set on extension. If in a particular portion in an image, if in an image only one connected set is there, that will be called a region of the image. This S is the region of the image. Only one connected set should be there, not more than that. This way, the region of an image is defined technically. Okay? So, now, if I ask you our initial image, which was this one, in that, which are the regions? I will say, if I take this subset and this subset, this and this separately. So, this is one region, this is one region of the image. Of the image, which one? This is the total image what I have considered, up to of which this one and this one are two different subset is taken there, which one is named as say R1, another is R2. So, they are the regions. Let me analyze them. So, those two regions are considered say in this way R1 and R2 there. Now, if you go to the individual elements which are say pixels, now you have made an arrangement so that some relationship is found between the pixels also in a particular section. Now, that you are calling as an individual component, which is a region here. Now, you may ask your computer, is there any connectivity between two regions? It is a simple question. If pixels are connected, in that case I want to extend it for regions are connected or not to check. That is also possible. If it is to be check the connectivity, I have to go for the adjacency. If I have to go for the adjacency, I have to go for either M8 or M. In that, V matrix is already, V set is already defined there. Say, we want to find adjacency between them. Say, 4 adjacency. In that, you will try to find if some adjacency of this pixels of this region and pixels of this region has their adjacency. Say like for this you are checking the neighbors there. Who will be the neighbors there? Only N4, not diagonals. Since I am talking about 4 adjacency, I found nothing actually. Nobody is there in the horizontal or vertical direction who will have the same one value. Fine. But I could go for diagonal. If I go for diagonal adjacency ND, but we do not define that, we have defined only 8 adjacency. Then I can go for finding the 8 adjacency. In that I found these two are having the same intensity V equals to offset with intensity value 1. So, I will say these two regions are 8 adjacent, not 4 adjacent. Okay. Next, another term like edge and boundary, which are sometimes people confuse. Edge and boundary, meaning is almost similar. But if you go for defining them separately, boundary is a global term actually, but edge is a local one from the meaning itself. English meaning itself you can derive it, that boundary means the overall thing and edge is a local portion of this. Just like see, this is an image given to you where ones are there, they might have considered one region in it. They have the connected components there in it where I am finding they are 1, 1, 1 like this. But circled one, see there, in that all are having 1, 1, 1, but only this is 0. Only one diagonal has gone to 0 of it. So, of this pixel or this location, since remaining are all having the adjacency with that region, but one portion or some portion of it, it is not adjacent to this. So, those locations will be called edges. But if you want to say boundary, in that case you have to have this kind of one overall thing where that uniformity of that discontinuity of the intensity or adjacency values should be there. Just like since here 1, 1, 1 are there, they are adjacent to one another. But next to them, see these zeros, they are not connected. So, in this case, this many components are there around it who are having discontinuity from the actual region, which I have found a separate portion of the image there. So, this global thing will be called as boundary of the image, but not here. If you want to find the boundary, then in that case boundary should come like this. Boundary is bigger one, but if you say edge of it, edge is here. Why not here? Here it is edge, obviously edges will be there, they will be in a cumulative manner, they will be giving a boundary. If all are edges only of a circle, if you find all the points, individually their edges they are giving. Finally, if you cumulatively if you see there, they are actually of discontinuity to the circle there. So, the boundary of the circle can be found with that idea. Usually same idea is kept here also. But only thing is that local and global concept should come in between. Another one, distance matrix. If you are traveling a path, how much path you are traveling? That may be the question. May not be always the unit length what you have or the adjacencies what you have found, and then you have put the lines there, and in that you are finding how many pixels interpixel movement has happened there, or how many individual unit length of that was there. That may not be always satisfactory actually. You can go for absolute distance of the screen also, means from here to here. That distance I may like to measure there, just like Euclidean distances are all. That is purely the difference between two coordinates and square of them and square root of that one, like that example I am saying about. If you want to get the distances in the image, in that to define that, let us find this is an image or sub-image of an image. In that these are the points P, Q and Z. These are the 3 pixels who have the coordinates like this, respectively x, y, s, t and v, w. They are the absolute coordinates what we talked about. A coordinate of interest p, p within bracket x, y. That x, y I am talking about. So, that x, y one has, for p it is x, y, it is s, t and this is v, w. This is known to us, or our system knows that location of individual pixels because it knows its dimension and its arrangement of the x, y values from 0 to m, n. So, if you know those, just put your idea of mathematics which are actually given here. 2 points are there, P and Q. If you say dPQ is greater than equals to dQ, P, Q, Q, P, sorry, Q, P. How it can happen? Greater than is not possible, equal is possible. That can be 0 only if they are the same point. Oh, PQ is said there actually, it is said, fine. Then come to this, they can be equal if they are, if P and Q are interchanged, still they are equal. You can take either way because you are finding the distance between them. Okay, but go for this one. Say you are finding the difference between P and Z. In that case, one condition may be put there, sum of these two will be always greater than that one. This is quite obvious for geometry. Okay. So, this way some ideas are there, and with that absolute Euclidean distance if you want to find between 2 pixels, say P and Q, you will be taking the coordinates of P, x and y and coordinates of Q, s and t. You will be getting the subtraction of those two in corresponding, then square, then add, then take square root of that. This is that Euclidean distance which is also used for measuring the distance between 2 pixels. 2 more I will be discussing here. One is called city block distance, or sometimes diamond also it says. It is a distance between P and Q, means 2 pixels, which is called D4. The 4th term you already know. What is that 4 basically? 4 means it is a 4 neighbor, it is talking about 4 neighbors actually. Okay. So, in that if D4 PQ if you want to find out, in that case you have to take x minus x mod of that plus y minus t mod of that and simply add them. If you find that distance, that will be called a D4 distance between 2 pixels P and Q who has the coordinate x comma y and s comma t. This is the definition for this D4 P comma Q. Now, my question is that if this is the definition of D4 PQ, how the pixels will look like if I define a distance? If I define the distance D4 less than equals to 2, that means x minus s and y minus t, summation of those two without their sign, means difference of those two and then add them. That should be always less than 2. If I want to find in the pixel, you will get like this. 1 is made for less than equals to 1 and 2 are marked for less than equals to 2. What might be the reason for defining this kind of distance practically? That is fine, that is the mechanism through which we go, but practical application I am talking about. People may like sometime to consider the things in a circular manner, or sometimes search is easier to go in this fashion, which is a diamond kind of search. For search engine, this becomes easier sometime to search those points who are making a diamond shape there. Okay. So, in that case, they will be traveling the diagonals like this. Okay. In that case, I could say only D4 equals to 2. If I would say D4 equals to 2, that means all 2 will be only there, remaining will not be there. So, I had to visit that rhombus only. Okay. This is the meaning of this in practical application. Similarly, if you go for another one where it is about the distance which is named as D8, distance between P and Q, which is the coordinate x comma y and s comma t. In this, we will take difference of those two. Out of those two, which one is the maximum, we will take that, and that we will define as D8. We will take the difference and we will take the maximum of it. If that way I define D8, and for that I ask your engine to search that find those who are having D8 less than equals to 2, you will be getting this kind of shape. It is for 1, it is for less than equals to 2, or only equals to 2 means this 2's, only equals to 1 means this one, where you are going just like through like a chess board, what you see, that way you are proceeding. Okay. So, that way the name has come like that, but for D4 distance, these are found with this logic only, by taking the difference of the coordinates and getting maximum of it with the number of this value which is defined there. So, computers are much more comfortable with this kind of definitions, so that their engine become faster to search the pixels, because in image processing you will see there you have to visit so many places there and the size is so huge. Okay. So, this kind of efficient techniques are there and also getting developed day by day. So, in the next class we will go for directly processing of images or arithmetic processes of images. Thank you.